This is Michael Aldrich. I have a huge podcast due tomorrow, but I haven't even started. I need to sleep. Hopefully, I'll get some inspiration. Alright, guys, today we're going to be taking a look at the unit circle, and that means that we're going to be constructing our own unit circle, looking at the sine and cosine values of different common angles and seeing how they relate to the sine and cosine waves, where sine is the y value and cosine is the x value. So to start off, we go into the graph tab and we show the grid. And then we click on the right endpoint and we zoom in just like so until you're at a point where you'd like to be. I'll zoom in this far. Next, we're going to construct a circle with a center A and a radius of 1. And as you see, the dot clicks right on. We're going to deselect everything, and then we're going to construct our own radius from 0 out to -1, and the circle will highlight when you get out to it, as seen there. Next, we're going to deselect everything, and then just select the line segment we created, and we're going to transform that 3 times by rotating it pi over 2 radians. And we're going to do that 2 more times. And once that happens, we're going to select all 4 of those line segments we just created. We're going to transform and rotate those pi over 6 radians. And we're going to do that twice. I'm just going to transform, rotate, do it one more time. And then finally, we deselect all by getting off, and then we select the 4 segments we originally created on the x and y axis, and we transform those and rotate them by pi over 4 radians. Next, we're going to go to our point tool, and we're going to put a point on each of these lines, making a line segment from the center to the radius that we've selected. Once you do that, you select all of it, and the next thing we do is label all these points. As you can see, I was able to label these in a like way, and you'll see that in a little bit. And so what we're going to do first is select all of these different points and go under the Measure tab and select Coordinates. And with those coordinates, we're going to put these by the ones that they're labeled. So C we'll put with C, and so on and so forth until they're all done. Once that's done, we're going to deselect everything, and then we will look at their relationships. And so, as you can see, if you look at G, H, I, and J, all of these have the same coterminal angle of pi over 6 degrees, which is the same as 30 degrees. And the x and y coordinates are all the same for G, H, I, and J, except some are positive and some are negative. And a good way to remember this is that the x value is the cosine of that angle. So the cosine of pi over 6 degrees is going to be 0.87. And to prove that, we're going to go over to number, calculate cosine of pi, just type in p, divided by 6. We're going to hit OK. So that comes up, and it's 0.87. Whoa, that's pretty cool. And if you look at the sine of that same angle, you go to number, calculate sine of pi divided by 6, hit OK, you get 0.5, which is the same here. And you can do that for any of these angles and it'll all be the same. So as your angle changes, so too will your x and y coordinates, and that'll form your sine and your cosine waves. So what we're going to do now is track this sine wave specifically. You can also do it with the cosine, but we're going to look at it with the sine wave. And so what you do first is make a line segment that's larger than segment BD. Doesn't really matter. And so then you will put a point on your circle that is not D, and we're going to make a line segment out of that and a radius and connect those. Now we're going to label the point on the circle that we just made, and for me that came up as S, and then we're going to put a point on the line segment and we're going to label that. Next we're going to put a perpendicular line through T and a parallel line through S to the line segment BT. And we do that by selecting the line segment and selecting T, going to construct a perpendicular line. And we'll move these out of our way now that that example's over. We'll just delete them. And then we go to S, that point we made, and select that line segment again and go construct parallel line. And that created an intersection point. And so what you do is put a new point on the intersection. We're going to label that. After this is labeled, we're going to change our coordinate system to trigonometry. So we go to graph, grid form, trigonometric axis, and that'll give us a better view of what's happening. And we're also going to extend our line segment to exactly 2 pi. And to make sure we do that, we're going to select this point that we created at the end of our line segment, and we're going to measure the abscissa, the x-coordinate of that. That showed up over here. We'll drag it over here. That's 6.49, and 2 pi is approximately 6.28. So we just drag it down to 6.28, and there we go. So we're done with this, and so we can delete that value. So next what we're going to do is look at how the point U moves as we move S around the circle. As you can see, it goes up and down when we move S. And when we move T, it goes along the x-axis parallel to it. And so what we're going to do is we're going to track U by selecting U, and we're going to display, and we're going to select trace intersection. And then what we're going to do is move S down so we can make an angle, measure our angle by using the marker tool, starting at B and dragging out. And you can barely see it, but it's there. And then we're going to select that angle. Yeah, let's see if we can do this better. And once we select that angle, we're going to go to Edit, Properties, Marker, and we're going to go counterclockwise because that's how our angles work in radians. So we say OK, we hit Escape twice, which will clear our traces that we just did, and then we're going to move the way it moves as S moves and T moves. So we'll escape from that and we'll select T and S, and we'll go to Edit, Action Buttons, Animation, and we'll make sure that T is moving forward, and we'll click OK. And we're just going to label this Sine Tracker, so we label Action Button by right clicking. We're going to call it Sine Tracker. Okay, then let's see what happens different this time. So, as you can see, the sign of 0 over here, if you look at D, it says the sign is 0, the Y is 0. And if you look over here at the point 0, 0, that's where our trace is going. And so you can track this all the way along, and a way to do that would be to select U and go to Measure and get the coordinates of U. It's highlighted over here, so we'll go over here and you can track it. So we pause it here, and a little after pi, the angle measure of pi, the x value is 3.23, which is a little over pi, and the y value, which is what we really care about right now, is a little below 0. And so if you look at it, you can see that it is just about 0. So you can do this all that you want, and there you go. I got it.